Hello guys, ¿qué tal? Today we are back with another video on the series of anti-infectives, and today we are going to discuss about anti-protozoal agents. So without much delay, let us get started. So first off, what are protozoans? So protozoans are single-celled eukaryotic parasites which belong to the kingdom of Protista. So they are single-celled, they are eukaryotics, and they act as parasites belonging to the family of Protista. Next are anti-protozoal agents. So anti-protozoal agents are the drugs which act against protozoal infections. Now what are the different types of protozoal diseases? In protozoal diseases, we will remember the acronym GT MALT. Just remember like GT mol, and we convert the last L to T. So GT MALT. So here we have giardiasis, toxoplasmosis, malaria, amoebiasis, leishmaniasis, and trypanosomiasis. Now giardiasis is caused by Giardia lamblia, toxoplasmosis by Toxoplasma gondii, then amoebiasis by Plasmodium ovale, Plasmodium falciparum, Plasmodium vivax, and many others. Next, amoebiasis by Entamoeba histolytica, leishmaniasis by Leishmania tropica, trypanosomiasis by Trypanosoma brucigambans. Next, we have antiprotozoal drugs. So we will look at all the antiprotozoal drugs according to the disease which they cause. So anti-giardiasis drugs we have metronidazole and tinidazole. Anti-toxoplasmosis drugs we have pyrimethamine. Anti-malarial drugs we have mefloquine, chloroquine, quinine, quinidine, artemisinin like artemether, arteether, primaquine. In anti-leishmaniasis, we have sodium stibogluconate, that is SSG, amphotericin B, and paromomycin. In anti-trypanosomiasis drugs, we have nifurtimox, pentamidine, suramine, benzonidazole. Now, GMT. Okay, so you will remember GMT, that is giardiasis has the drugs metronidazole, tinidazole. So for this we will remember GMT. GMT. So giardiasis, the drugs for giardiasis are metronidazole, tinidazole. For toxoplasmosis we have pyrimethamine. So TPP. Toxoplasmosis we have pyrimethamine, which is a drug which is also used for malaria. Next we have malarial drugs. So all the common malarial drugs we can list out: mefloquine, primaquine, chloroquine, quinine, quinidine, artemisinin. Next we have anti-leishmaniasis. So in anti-leishmaniasis we have SAP. So LSAP, where S would be SSG, that is sodium stibogluconate, A is amphotericin B, and P is paromomycin. In anti-trypanosomiasis drugs we have nifurtimox, pentamidine, suramine, benzonidazole. Next we have the anti-amoebiasis drugs. Now the anti-amoebiasis drugs are the most important class here in antiprotozoal drugs. So anti-amoebiasis drugs we have divided into two, that is tissue amoebiasis and luminal amoebiasis. So when the amoebiasis occurs in the lumen of the intestine, we will call it luminal. But when it happens to the tissues, that is the intestinal tissue or somewhere else, that is extraintestinal, we will call it tissue amoebiasis. So in tissue amoebiasis, we have intestinal amoebiasis, extraintestinal amoebiasis, and both intestinal as well as extraintestinal. So for intestinal amoebiasis, we will go for idoquinol. So remember intestinal idoquinol. Then we have extraintestinal amoebiasis. In this, we will go for chloroquine. So EC, EC. Then both intestinal as well as extraintestinal, we will go with nitroimidazoles and alkaloids. Now both, if it is intestinal as well as extraintestinal, we'll have to give it systemically. So systemically we can give nitroimidazoles as well as alkaloids. So nitroimidazoles we have metronidazole, ornidazole, secnidazole, tinidazole, and cetronidazole. So most people will like to take a leave on Saturday. So metronidazole, ornidazole, secnidazole, tinidazole, and cetronidazole. Next we have alkaloids. So in alkaloids we have amytid and dehydroamytid. Next we have the luminal amebicides. So when the lumen of the intestine is affected, we will call luminal amebiasis. Luminal amebiasis, we will give amides. So which all amides we will give? We will give diloxanide furoate and nitazoxanide. And in 8-hydroxyquinolines, so in 8-hydroxyquinolines we have iodoquinol and cleoquinol. In antibiotics we have tetracyclines and paromomycin. So we will remember this as AHA. So for luminal we have AHA, that is amides, 8 hydroxyquinolines, and the other A would be antibiotics. So let us start with the structure of metronidazole. Now what is the structure of metronidazole? If we look at the name metronidazole, so we will have metronidazole, idazole. So idazole means it is a imidazole. So first we will draw an imidazole ring. Next we will go for metro. So this is an imidazole ring. Next we will go for met. So met means methyl group. So here in between the two nitrogens we will give a methyl group. Next we have a pro. Pro means a nitro group. So on the opposite sides of the nitrogen we will give a NO2. So this is a nitro group. And then we have a metronidazole. Metro ET. ET means ethyl group. So CH2, CH2, and since we have an all in the end, we will give a OH. So this is the structure of metronidazole. Now let us look at the MOA of metronidazole. They reduce the nitro group intracellularly to give nitroso containing intermediates which will bind to the DNA, disrupt the structure, and inhibit bacterial nucleic acid synthesis, leading to the bacterial cell death. Now what do they do? The nitro group which they have in their structure, this one is reduced intracellularly, that is inside the bacterial cell. It is reduced to give nitroso containing intermediates, that is free radical generation. Now due to these free radicals will go and attach to the DNA. Now if this go and bind to the DNA, it will disrupt the structure of the DNA, that is a helical structure, and it inhibits bacterial nucleic acid synthesis. So if you inhibit the DNA, there would be no production of nucleic acid. Now since there is no production of nucleic acid, this leads to the death of the bacteria. Next we have the uses. So the uses are, as we said, metronidazole, it is used in giardiasis, amebiasis, that is hepatic and intestinal, and then we also have a use in Crohn's disease. Next we have pyrimethamine. So in pyrimethamine we will have pyrimethamine. Pyrimethamine belongs to the group of diaminopyrimidines. So diaminopyrimidines has the basic structure of a pyrimidine, that is two alternate nitrogens with double bonds in a 6-membered ring, and then we have two NH2s, that is two amino groups attached to it. So this is a structure of diaminopyrimidine. Now since it is a synthetic derivative of diaminopyrimidine, we will attach this to another ring. Since this chlorine moiety is very important for its antimalarial action, we will add a chlorine here. Now it says diamidopyrimidine is the basic structure. The main name is pyrimethamine. So pyrimethamine, that is we will have another ring, methamine. Meth means pyrimidine. This eth is extra, so we will add an ethyl group right here, C2H5. So pyrimid, this is diaminopyrimidine, pyrimid, then ethamine, that is ethyl group, and since it's a diaminopyrimidine, we will call it pyrimethamine. Now what is the MOA of pyrimethamine? It inhibits dihydrofolate reductase in the plasmodia, and thereby the developing parasite cannot synthesize and use nucleic acid precursors needed for their normal growth. Now, dihydrofolate reductase, this enzyme is used in the production of folic acid. Now, folic acid is very essential for the production of DNA and other nucleic acids. So, since there is an inhibition of DHFR, the plasmodia cannot synthesize or use any nucleic acid precursors such as folic acid, and therefore it cannot grow normally. That is, uh, the precursors which are needed for the normal growth are not available, so it inhibits the developing of the parasite. Now, it is used in the prophylaxis of malaria, which is caused by Plasmodium falciparum and Plasmodium vivax. Now, this will be given for prophylaxis in areas which have a very high risk of getting malaria, and it is also used for the treatment of toxoplasmosis and is also used as a immunosuppressive agent. Next, we have pentamidin. Now, pentamidin, this is taken from the word amidin. So, amidin is the basic structure here. Now, what do you understand by amidin? Amidin is the substitution of an imine group to a amide group. So, how do we draw a structure of amide? Amide is C double bond O NH2. Now, if you substitute this double bond O for a imine, which is NH2, for a NH, that is a imine, we will get a amidin, that is C double bond NH and an NH2 group. Now this is your imidin. This is your amidin. So we will use this structure in pentamidin. Now penta, what does penta mean? Penta means 5 carbons. So we will have 1, 2, 3, 4, 5. 5 carbons here. This is a pentane chain. To this we will add an oxy group, that is oxypentyl group here. So we will have a mirror image right here. So we draw a 5 chain carbon first. 1, 2, 3, 4, 1, 2, 3, 4, 5, and so we draw an oxygen and we give a 5 carbon chain. 1, 2, 3, 4, 5, another oxygen. Then we just draw a mirror image here, both the sides, a benzene ring right here. To this benzene ring we shall give an amidin ring, that is C NH2 double bond NH. The same thing here, C NH2 and a double bond NH. Now this is not done. We will give a point to OH CH2 CH2 HSO3. Now this is the structure of pentamidin. Now next we have the MOA of pentamidin. It interacts with the minor groove of the AT-rich DNA region of the pathogen genome, and it interferes with the DNA replication and function. So this is how it inhibits the growth of the pathogen. That is, it interacts with the minor grooves of the AT, that is adenosine and thymine rich DNA region of the pathogen genome, interfering with DNA replication and function. Now it is used in the treatment of trypanosomiasis, leishmaniasis, and pneumocystis carinii pneumonia, that is PCP, in HIV infected patients. Now PCP is a very common co-infection, or it is an opportunistic infection seen in HIV infected patients. Next we have chloroquine. So For this chloroquine, the MO is the parasite utilizes host hemoglobin for the essential amino acids and heme is released. Now, as we know, hemoglobin has two parts, heme and globin. Now, the heme part is toxic, whereas the globin is used as an essential amino acid for the parasite. So, now since the heme is toxic to the parasite, so it converts heme to hemazoin. That is, heme is toxic, hemazoin is non-toxic. Now this is done by the enzyme heme polymerase. Now chloroquine inhibits heme polymerase and heme accumulates and is toxic for the parasite. Now parasite will feed on the hemoglobin. Parasite will feed on the hemoglobin. Now this hemoglobin will release the amino acid and the heme. Now amino acid will be utilized by the parasite as an essential amino acid for its survival. Now hemoglobin will also release a toxic metabolite, that is heme. Now since this heme is toxic for the parasite, what it will do is it will convert this into hemazoin by heme polymerase. Now this conversion of heme to hemazoin, which is a non-toxic substitute, is inhibited by chloroquine. Now since chloroquine inhibits the heme polymerase, heme accumulates in the parasite and is toxic for the parasite. So it leads to the death of the parasite. Now how do we draw chloroquine? Chloroquine is a 4-amino quinoline ring. Now how do we draw 4-amino quinoline? We will draw a basic ring of 2 benzenes attached to each other. Then we have a nitrogen right here, a chlorine right here, and then we have a hydrocarbon chain. Now since it is a 4-amino, in the 4th position we have a amino group, a chlorine group right here in the 7th position. So attached to this ring we will have a hydrocarbon chain. So for chloroquine we have 2 benzene rings fused to each other. Next we have a nitrogen here and a N group here, and then we have a chlorine group right here. We will give this one an H, and then after this what we'll do is we will add 2 mountains, the half of the 3rd mountain, a nitrogen right here and a mountain here, and then to this first mountain we will add a stick on the mountain. Second, nothing. Here we have a nitrogen and attached to this 2 CH2 CH2 group, CH2 CH2 group. So this is a structure of chloroquine. Next we have iodoquinol. So the exact mechanism is unknown, but it acts in the intestinal lumen and as an amebicide, mainly due to its ability to chelate metal ions. Now it is used in acute and chronic intestinal luminal amebicidal diseases, but it's not used in extraintestinal disease. Now for the structure of iodoquinol, as we know that iodoquinol belongs to the group of 8 hydroxyquinolines. So first we will draw the structure of 8-hydroxyquinoline. So 8-hydroxyquinoline has a structure which looks something like this. There is a OH group here in its meta position and its para position. So what we will do in iodoquinol is iodo. Remember, iod. D means 2. Io means iodine. So 2 molecules of iodine. So we will place this OH right here with iodine and this OH right here with iodine. Iodoquinol will look like a benzene ring. In place of this and this OH we have I groups, and OH here will give it its normal double bond, and then we have another 6-membered ring in which we have a quinine structure, that is a benzene ring with a nitrogen. Since it's quinol, we'll have quinine which has a structure of 1 nitrogen, 6-membered ring with double bonds. So we have iodo and then quinol. So this is the structure of iodoquinol. Next we have the synthesis of metronidazole. So in metronidazole, our starting product would be glyoxyl, that is two aldehyde groups which are fused to each other. Then we have two molecules of ammonia and acetaldehyde. Now when the cyclization happens here, we will get 2-methyl imidazole. So 2-methyl imidazole will undergo nitration, that is in the presence of nitric acid and sulfuric acid, and it will give a nitro group right here. So from 2-methyl imidazole it will go to 2-methyl 5-nitroimidazole. Next we have, in the presence of NaOH and chlorethanol, this is ethanol and there is a chlorine added to it, so chlorethanol, we will get metronidazole. That is, this ethanol group will be transferred to this nitrogen right here, and we will get metronidazole. So that's all we had for today. I hope you all enjoyed the class. I hope video was interesting. If you liked it, please like the video, subscribe to our channel, and we will be back with such videos next week. Until then, bye bye. Have a nice day. Mogas.